Welcome to Ask and Learn.
Okay, well, in this problem we have a Carnot cycle and we need to find the network per cycle in this problem. So let's put here the network per cycle. Remember that we can use the efficiency of a thermodynamic process, which is going to be described by the network divided by the input heat. Okay? Therefore, we can say that the net work is just the efficiency of the thermal reservoir, thermal system, multiplied by the heat input. And the only problem we have here is to find out who is the efficiency of the thermal reservoir, which in this case is going to be the efficiency of a Carnot cycle. And we know that the efficiency of a Carnot cycle is just TL TH1 minus TLTH, and this is going to be 1 minus 300 divided by 1100 in this particular problem, which gives us an efficiency of 72.7%. Okay? The second thing we must find is the heat input. So who is the heat input? The heat input in a Carnot cycle is just M R TH, because it's the temperature of the high energy reservoir, natural log of V2 V1. Okay, because it's the transitions where we are working with the high energy input. So the problem is we do not have the initial the volume 1, neither the volume 2. So we can use the ideal gas law and change this to M R, this should be a R, TH, natural log of P1, P2. Okay, that is much better. But again, we do not have pressure 2. So we can use the transformation between 2 and 1 because we know it's an isentropic transformation. And since this is an isentropic transformation, we can rewrite again the heat input as MRTH, natural log of P1, P3, that multiplies TL, TH to the power of K, K minus 1. Okay, so it's a little ugly, but we just need to use in P2 the isentropic transformation for the pressure. And substituting all the values, we find that the network that we want, so let's put here the network is going to be 72.7%. That multiplies the mass, which is 0.6. That multiplies R, which is 0.287. We have a point in here. Times the temperature of the high energy reservoir. Natural log of 3000 divided by 20. 300 divided by 100, 1100 to the power 1.4 divided by 0.4. Using a calculator, we discovered that the network is going to be precisely 63.8 kilojoules, which is the final answer to this problem. Thanks for watching.